All right, this video is going to cover solution stoichiometry. So same general idea as what we were looking at in the previous video on gravimetric stoich. Biggest difference is going to be instead of having masses or potentially moles, you're generally going to be dealing with concentration and volume because that's usually what we have when we are dealing with solutions. Okay, we're still going to follow those same general steps that we had talked about. We're going to start by writing our balanced chemical equation, listing all of our givens out. Then we're going to think about what is the unit we are trying to solve for, and then we're going to start our unit analysis, with whichever given has the unit we are looking for, and then we're going to keep going until we cancel everything out. Also, obviously, being mindful of our significant digits as we go. Okay, so first example. Okay, so zinc metal reacts with hydrochloric acid to produce zinc chloride and hydrogen gas. Sorry, that D got cut off. What mass of zinc chloride can be produced by reacting 50 mils of 1 mole per liter hydrochloric acid? So, like we said, our first step is going to be to write that balanced chemical equation. So we are going to have our zinc, which is going to combine with our hydrochloric acid, so HClEq. Okay, this is a single replacement reaction, so we are going to make zinc chloride. Okay, if we check our solubility table, this is soluble, so it's going to be aqueous. And then we make our element, which is going to be hydrogen, which is H2 gas. Okay, we need to make sure that we balance it, because if we don't have our balance right, we are going to wind up using the wrong ratio when we get into our calculation. Okay, so now that we have our balanced chemical equation, our next step is to determine what it has asked us for. So it's asked us to find the mass of the zinc chloride. So because we are looking for mass, we are going to need a molar mass. So 65.41 plus 2 times 35.45, we get 136.31 grams per mole. Okay, so what are we given? We were told the hydrochloric acid, right? We were given a volume. Remember, we want to convert that milliliters over to liters, so 0.0500 liters. And then we were given a concentration of 1 mole per liter. Okay, so if we take a minute, think about the unit we're trying to find. We are looking for mass of zinc chloride. That means we need to get grams. So underneath the zinc chloride here we have grams. It's already on the top, which is where we need it to be able to solve for it. So we are solving for the mass of zinc chloride. So we're going to say that it's going to equal, we're going to use that 136.31 grams. We're going to put that per mole of that zinc chloride. Okay, so now we need to get rid of moles of zinc chloride, so we're left with just grams. So the only other moles we have is here, and that's hydrochloric acid, so we're going to use that ratio, right? Remember we said in the previous video that when we're doing stoich, we're pretty much always going to have a ratio. So let's use that ratio. Because we need to get rid of zinc chloride, it's going to go onto the top. So 1 mole of zinc chloride up here. And then on the bottom, we're going to put 2 moles of HCl. Okay, so by doing that, we can now eliminate the unit moles of zinc chloride. Next unit we need to get rid of is going to be that hydrochloric acid. Okay, so to get rid of moles of HCl, we look at HCl. Here we have moles of HCl. It's on the top, which is where we need it to be able to cancel it out. So we're times by that 1.00 mole of HCl per liter. Okay, so now we look at our units and we're now able to get rid of moles of HCl. So last unit we need to get rid of, so that we're left with just the grams, which is what we want, is this liters. So we haven't used this yet, the volume, so we can go ahead and use that. We know to get rid of liters, it has to go on the top. So we're going to times by 0.0500 liters, and we will just put that over 1. Okay, now we can get rid of liters. Oh, I don't know how I made that tilt sideways, but all right. So we have that. And now we can just go ahead and type this in our calculator and get our answer. So 136.31 divide by 2, and then times it by 0.05. So significant digits, we can have 3, so we get 3.41 grams as the mass coming out of that, okay? So you'll notice that this question used a little bit of solution, right, because this was a solution, but that it was asking us to find a mass, and that's pretty common to see that the two get mixed together. So you'll notice over here for the HCl, we never went and got a molar mass, and that's because we didn't have a mass, so we weren't looking for a mass, right? We said yesterday, or not yesterday, I guess in the previous video, when we were looking at gravimetric stoich, that we only need molar mass if we actually have a mass, or are looking for a mass. Okay, next example. Okay, so this question says if 50 mils of 0.100 mole per liter sodium hydroxide is required to neutralize 18.5 mils of hydrochloric acid, what is the concentration of HCl? Okay, so from here we're going to write our balanced equation. So we have sodium hydroxide, which we are combining with that hydrochloric acid. Okay, it's a neutralization, technically a type of double replacement, but specifically we are making water. And then we're going to make our ionic compound, which in this case is going to be that sodium chloride. Okay, when we check this equation, everything is already balanced, so we don't actually need to do anything to balance it. So start listing our givens. So for sodium hydroxide, we are given the volume is 0.0500 liters. We are also given the concentration as 0.100 moles, and that would be per liter. And then for the HCl, we were given a volume of that as 0.0185 liters. And we were looking for the concentration, right? That was our unknown. So we think about the fact that we're looking for concentration. We're looking to get moles per liter. And we're specifically looking to get moles of HCl per liter, okay? So set up our unit analysis. So concentration of HCl is going to equal. So if we're trying to get moles of HCl per liter, we can either start by placing the liters, or we can start by placing the moles. It really doesn't matter what you choose to start with. So let's just place the liters because we already have that. We know that it's moles per liter, so that tells us that it has to go on the bottom. So we're going to put 1 over that 0.0185 liters. Okay, so now that places the liters on the bottom where we need them. The next thing we need to place is the moles of HCl up here on the top. So I don't have moles of HCl written under here, but again, that's okay because we can go ahead and use our ratio to do that. So 1 mole of HCl, and then because all our other given information is for the sodium hydroxide, we can put that over 1 mole of sodium hydroxide. Okay, so now we've placed moles of HCl and we've placed the liters. Now we have to start getting rid of the other stuff. So we have to get rid of moles of NaOH. We can get rid of moles of NaOH using the moles of NaOH that we have in here. So we're going to times by 0.100 moles NaOH, and that's going to be per liter, right? Because that's what we had in here. So that now allows for us to eliminate moles of NaOH. We need to get rid of this liters, right? Because this isn't the right liters. We already have the correct liters, okay? And I know that this is the correct liters because that's associated with HCl, right? This liters here is associated with NaOH. So how we're going to get rid of liters of NaOH? Look at that. We have liters of NaOH written underneath it. So we're going to times by that 0.0500 liters. And again, we can just put that over 1. And now when we look at it, we can cancel out those liters that were associated with the NaOH that we didn't want. And now unit-wise, all we're left with is the moles of HCl per liter of HCl, which is what we were always looking to get. So we do 1 divided by 0.0185 times 0.1 times 0.05. So remember, we have always said 1s aren't really important. The only time a 1 is important is when the first order, or not order, the first thing you need to do is a division, right? I can't just type in my calculator divided by, I have to do something divided by. So really the only time I need a 1 is if like there's nothing here. Otherwise we can just kind of go across and usually we can ignore the ones. You can definitely still put the ones in your calculator, it won't matter, But if you think about math, you divide by 1, you multiply by 1. It doesn't actually change your number. Okay, significant digits, we can have 3, so 0.270, and that is going to be moles per liter. Okay, so this is what you call like a true solution Stoic question, because both things were solution. We had concentrations and volumes for both of them. Okay, so here's another example. Very similar to the last one, the wording is just a little bit different. So it says, what is the minimum volume of 0.250 mole per liter magnesium chloride needed to precipitate all the silver ions in 100 mils of 0.3 mole per liter silver nitrate? So balanced equation comes first. So magnesium chloride plus silver nitrate. Okay, this is going to be a double replacement reaction. So we are going to make magnesium nitrate, so MgNO3, and then a 2, right? We have to do that because magnesium has a 2 charge and nitrate has a 1 charge. Check your solubility table. It's going to be aqueous. And then our other product is going to be that silver chloride. Okay, and this time if we check our solubility table, this one is actually solid. All right, we need to balance. So a 2 in front of the AgNO3 and a 2 in front of the AgCl. Right, so step 1 is done. There's my balanced chemical equation. Move on to step 2, which is to list my givens. So for magnesium chloride, we had a concentration of 0.250 moles per liter. We were looking for the volume of this one, right? That is our unknown this time. Let me just move that up a bit, line it up a bit better. Okay, and then for silver nitrate, we were given the concentration of 0.30 moles per liter. And then we were given the volume as 0.100 liters. Okay, so next step, think about our givens and what we're looking for. We're trying to find the volume, which means we're looking for liters. We're trying to find the volume of magnesium chloride. So although all 3 of these have liters, the right liters would be this one here because it's associated with the magnesium chloride. So for me to solve for that, I'm going to have to flip that over, right? Because we've always said that whatever variable or unit we're looking for, we have to make sure that's placed in the right spot. We're not looking to get 1 over a liter, we're looking to get a liter. Okay, so to solve for the volume of magnesium chloride, we are going to start by taking that concentration and flipping it. So we're going to do liters over 0.250 moles of MgCl2. Okay, so that has now placed my liters. I need to get rid of moles of MgCl2. We're going to do that using a ratio, right? Because I've already used this piece, I can't use it again. I don't have any other given underneath here that involves that. So on the top, we are going to say 1 mole of MgCl2, and on the bottom, we're going to say 2 moles of AgNO3. Okay, so now, looking at our units, we should be able to cancel moles of magnesium chloride. Okay, next unit to get rid of is this one here, the moles of silver nitrate. So look at silver nitrate, this has moles. To cancel the moles, it needs to go on the top. It's already on the top, so we're going to do times 0.30 moles AgNO3, and that's going to be per liter. Okay, so now we've canceled out moles of AgNO3. Last thing we need to get rid of is this, right? Because all we want left is this liters here. If I stop now, I might actually cancel out liters and then I have no units left, which is definitely not what I want. Okay, so to get rid of the liters of AgNO3, we will use the volume of AgNO3. So 0.100 liters. Just put that over 1. Now we can eliminate that last unit. All we're left with is our desired unit, which is this one up here. Okay, so in our calculator, 1 divided by 0.25, divide by 2, times by 0.3, and then times by 0.1. Okay, and then we are going to get the volume is equal to 0.06, 1 more sig dig, 0, and that would be liters. Or if you really want, you could also write this in terms of milliliters and say that it's 60 milliliters. Okay, last question. All right, so this one is a little different. So it says, what is the concentration of hydrochloric acid if 200 grams of aluminum are placed into 250 mils, and following the completion of the reaction, 188.04 grams of aluminum remain? So still going to start by writing my balanced equation. So it's aluminum plus, that's not a plus, that's plus, hydrochloric acid. Okay, it's going to turn into, this would be a single replacement reaction, so we're going to make aluminum chloride, so AlCl3. Solubility of this one, I actually have to look this one up, give me a second. I want to say it's going to be soluble, but I could be wrong. Nope, it's going to be soluble, so it's going to be aqueous. And then we're going to make our new element, which is going to be that hydrogen gas. Well, that didn't go in subscript. Okay, so next thing we need to do, that's not subscript either, there we go, is going to be to balance this equation, right? So I have 3 chlorines here and I have 2 hydrogens here. To make this work, I'm going to have to put a 6 in front of that HCl so that I can put a 2 here and a 3 here. That's then going to mean that I need a 2 over here with the alumina. Okay, so this one is a little bit trickier to balance. Sometimes it takes a little trial and error. Okay, so that part of the question so far was the same. Okay, we know the volume of HCl is 0.250 liters. Okay, we are looking for the concentration of this. That's our unknown. So here's where this question is a little different, is it gave me the initial mass of aluminum, and then it told me that after the reaction I had 188.04 grams left over. So what I have to do is figure out how many I actually used, because I didn't use all 200 grams if I still had 188.04 left. So what we're going to have to do to figure out the mass of aluminum is subtract what we started with and what we used, or what was left, so we can figure out what we used. We're going to do 200 minus 188.04, and from that I get 11.96 grams. Okay, so I had to subtract these two numbers because this was the initial and this was what was left. So I had to subtract what was left from what I started with to figure out how much I actually used, right? If I used 200 grams, I would get a totally different number for this concentration. So important to make sure that you do really read the question so that you are getting that right information. Okay, molar mass of aluminum, 26.98 grams per mole. Like we talked about before, we need a molar mass for aluminum because I have a mass. Okay, it's only 26 because remember we also talked about how the coefficient we balanced with doesn't impact the molar mass, right? If there was a little subscript, I would care about that. But aluminum doesn't have a subscript, so I'm literally just looking up the molar mass of aluminum. Okay, so what we are trying to solve for is the concentration of hydrochloric acid. So that means we need to get moles per liter of HCl. So similarly to the previous question, we have the liters here, so we could start with that. So we can do the 1 over, that's 0.250 liters. Okay, so from that, I placed the liters part of the moles per liter. Now I have to place the moles part of HCl. When I look under HCl, there's nothing there, so we're going to use our ratio to help us do that. So it's going to be 6 moles of HCl over 2 moles of aluminum. Okay, so now I've placed the moles of HCl, I've placed the liters, it's just a matter of getting rid of everything else. We need to get rid of moles of aluminum. We look at aluminum, the molar mass has moles of aluminum. We are going to have to flip it over though, so that it's on the top, so we're going to do times moles of aluminum, and that is going to be over that 26.98 grams. Okay, so from there, we have now just canceled out moles of aluminum. Next thing we need to get rid of is this grams. You look at aluminum, we have the 11.96 grams. So we're going to do times by 11.96 grams. Again, making sure that the grams goes on the top so that it's in that opposite position so that we can actually cancel out the unit. And then from here, those grams are gone. So we've canceled out all the units we didn't want. We're left with moles of HCl per liter, which is what we were trying to solve for. So 1 divided by 0.25. times 6 divided by 2 divided by 26.98, and then times 11.96. Significant digits, we are looking at 4 from this and 3 from this, right? So I'm not really looking at these two here for significant digits because I didn't actually use those numbers in my calculation. I did a subtraction with them, which sig dig for subtraction is number of decimal places, which has 2, which is why this here had 4 sig digs, and this one has 3, so we're going to go to 3. So answer-wise, we're going to have 5.32 moles per liter as our concentration. Okay, so this is more or less what solution stoich looks like. As soon as you figure out how to do unit analysis, you're pretty much set. Because you should be finding, for those of you that are understanding this, this isn't really any harder than what you did yesterday. It's just a little bit different, okay?